Hi, and welcome to today's session on generating a sequence from the linear nth term rule. So all that we're looking to do is actually just generate a sequence from the nth term. So this we'll be doing if we're already given the nth term rule, and the question will normally say, can you please generate the first 5 terms of a sequence? Could you generate at least the first 6 terms of a sequence? So my example, I'm going to look through trying to create the first 4 terms of the sequence using the rule 4n minus 3. So to do this, I need to remember that my n is related to the position term of each value in my sequence. So position 1, position 2, position 3, position 4. So to generate my sequence, to create my sequence for my first term, I'm going to replace my n with the number 1 because I'm looking for my first term. So 4 times 1 gives me 4, minus 3, that does give me 1. So I've got 1 as my first number in my sequence. For my second term, I'm going to replace my n with 2. I'm going to substitute 2 in for n, which gives me 5. For 3, I'm going to substitute my 3 in for n, which gives me 9. And for my fourth term, I'm going to replace my n with 4, which gives me 13. So I've generated the first 4 terms of my sequence, the first 4 numbers, first 4 values of my sequence. The thing to bear in mind for these questions is that if it says to generate the first 4 terms, I've got to make sure I'm giving the question 4 terms because that's what it's asking of me. I'm not going to give it 5, I'm not going to give it 3. If it says at least 6 terms, we could give it 6, we could give it 7, 8, 9, because it said at least 6 terms. But if we had to look at the difference between these, just to confirm that it works, our difference between each one of these is plus 4, in which case this is related to our 4, which is in front of the n. Now, a quick way of being able to do this is that we've got 4n minus 3. Once we've found our first term of our sequence, so replace that n with 1 to find our first term, which is 1, we could, rather than working out each individual value for the terms by substituting in the position, we could literally just add 4 each time from the previous term to find the next number in the sequence. Again, just another quick way of being able to do it. So we could use this to actually predict if a number is actually within the sequence. So we could be asked, is 44 in the sequence of this rule? So 4n minus 5. Now, a few different ways that people approach this. Some people can continuously go up in the sequence to see 44 would appear. That's a good viable way of doing it. But I'm just going to show you how to do this using a bit of equations. So I'm going to put 4n minus 5 equals 44. So first thing I'm going to do is add 5 to both sides, or take my minus 5 from the left-hand side to the right-hand side, in which case it will become its opposite. My minus 5 will become positive 5. Now I'm looking to actually simplify this a tiny bit further. So 44 plus 5 gives me 49. Now I'm looking for the value of just a single n. So if I divide both sides by 4, or take my 4 from this side to this side, where it's multiplying on this side, become division on this side, my n equals 12.25. Now, I know that 44 will not be part of this sequence because I've got a decimal answer, or if you end up with a fractional answer. For 44 to be part of this sequence, I would need a full number, a whole number as my answer for this, or an integer. Because whatever number we get here actually tells us what position this number would be within the sequence. If you like what you see, please subscribe. Well, thank you very much for watching.